I want to do a video on a 24 volt HVAC circuit where we are going to be demonstrating voltage drop and where we can have voltage drop as it relates to an open circuit and a closed circuit and a resistive connection. So what I've got here is my thermostat terminal board here. I've got a switch, which could be a float switch or a pressure switch, overload switch, and I've got a 24 volt coil in this contactor, and this we'll be using a little later. This will simulate a resistive connection. This is 137 ohms, these 4 resistors in parallel. So what we're going to do here is, let me just kind of go over what we've got. So I've got 24 volts coming in here, coming in. This is my common. I've got 24 volts R coming in from my transformer, coming into one side of my switch, coming out of my switch. I've got my 24 volts coming over and connecting to the R terminal, and I'm going to take these off. This is coming over into my R terminal. So this could be like a float switch that's breaking R from the transformer. R is in series with this switch going into R on my thermostat. Coming out of the other side of my thermostat, I have Y, which is coming over, and it is connecting to the other side of my 24 volt coil or my compressor contactor. So common is always feeding, which is typical, and R is going through a float switch to R on my thermostat, to Y, which is connected to my compressor contactor. This contactor could be, this could be in a package unit, or this could be a remote in the condensing unit. That's remote. So I'm going to go ahead and turn the power on, and nothing is going to be coming on because my thermostat is not closed. So my thermostat's not calling. I do not have a connection between R and Y, which would be within the thermostat. So this would be as if you had the thermostat off the sub base, and so it's not calling for cooling. So I've got my voltmeter set to volts AC. I'm just going to check, and across R to Y, I have 28 volts. Now the reason why I have 28 volts is because common is being fed through my coil of my contactor to Y. There's no current flowing because I don't have a closed circuit. So this is where we get into when you're troubleshooting an HVAC circuit, where you can use the existing wiring like a continuity meter. So because I have common here, and I know it's common because when I go from here to my common on my transformer, I have 0 volts. And if I had that common coming over here to my thermostat, it would be the same. If I go between this R and common, I have my 28 volts. If I go between R and Y, I have 28 volts. So that common is being felt through the windings through to my Y connection. And what this is telling me is, when I take the thermostat off the wall and I'm checking this is telling me I've got R coming to the R connection. So it's not off on the float switch. My wiring, common and my Y going to my compressor contactor are good. as far as there's continuity, and the coil of my contactor is good because there is continuity. So it's basically, this is basically checking continuity using voltage. Okay. Now, this circuit's open, there's no current flow. Now, if I were to close the thermostat, so I put the thermostat back on the wall, or I jump out the thermostat, so I'm going to jump out the thermostat, and the contactor pulled in, and now across the contactor, I have my 27 volts, but between R and Y, I do not. I have 0, and that's because I've got R and Y jumped out. Now, if my float switch were open, my thermostat's still closed, but I'm not getting, so if I check between R and common, I'm not getting my 28 volts. Sorry. I'm not getting my 28 volts between those, getting 0. But if I check between the float switch or coming out of the transformer, so this is coming out of the transformer, this is power R going into the float, and I check between that and common, I have my 28 volts. So I've got R side of power going to one side of my float, but I don't have it coming out of my float. So if I check between here and common, get that on there, sorry. I've got 0, but if I go to the other side, I have 28. So my open is here. So actually, if I check across here, because I've got a closed circuit, I should have 24 volts because common is going to be felt through Y, through my thermostat, which is calling back to this point. This is my open. So if I check from here to here, I should have 20, and I do. I got 28 volts. It's because this is where my open is. This is where I'm dropping voltage. This is actually common is being felt through my thermostat that's closed. It's calling for cooling, and this point. So if your thermostat is calling for cooling, and you're trying to trace out where your open is, if you check across your float switch, you should have your low voltage. Now, if I have a thermostat off the sub base, I no longer have that connection at the thermostat. So common is going to stop right here. So if I go between here and here, I'm going to get nothing. And if I go between here and here, I'm going to get nothing. But if I go between here and why I get it. Now, why is that? Why do I have it between 24 coming into my float switch and here? Well, I've got an open here, my thermostat's not calling, and I've got an open here. So that's why when you're going to trace out a circuit for voltage drop, you're better off, if you're going to be leaving the thermostat, you're better off putting the thermostat in cool mode, fan on if you're tracing out the cooling circuit, fan on so you know the thermostat is closed. Then you can trace out your voltage drop to see where your open is. If your thermostat is off the sub base, then you've got an open in your thermostat. So you're not going to be able to, it's going to be a lot harder for you to trace out an open somewhere else in your circuit. Now, what I've done here is I have got, coming out of my switch, I've got that going into this bad connection. Now, this could be a bad wire connection, a rusty wire connection. This could be a rusty screw-on connector at a terminal. So this is a resistive connection. So it's a connection, but it's a very bad connection. It's a poor connection. Okay. And I'm coming off of that to R. So this bad connection is between my switch, we'll say float switch, and R. Now right now my thermostat's open. So what I want to show you is that I've got 24 volts on. I'm going to flip my switch on. And notice I've got 28 volts. But I've got a resistive connection here. So shouldn't I be dropping voltage across that bad connection? No, because there's no current. The circuit's open because my thermostat is not calling. My thermostat's off the sub base and it's open. So I'm going to read that. Everything looks normal. I don't see a problem here. But when I close this thermostat, the contactor doesn't pull in. If I check across here, I would expect to see 0, which I've got, because it's closed. Okay. Let me check across my transformer, my contactor, because I've got R feeding Y going to my contactor. So I check across my contactor, I've only got 3 volts. So my contactor's not pulling in. But if I pull the wire off my contactor, you only have to do one wire. Doesn't matter if it's common or Y. And I check, look at that, I got 28 volts. Well, that's strange. I've got 28 volts. But when I put it on, I'm just going to keep the wire attached, but I'm going to touch the contactor. It goes down to 3. Now, why is that? It's because when I close the circuit, current is flowing through this poor connection. That poor connection is going to drop voltage, and it's dropping 15 volts, or 25 volts. It's dropping 25 volts across it. And I'll show you that, because I'm going to connect this back up, right? Now, I've got current flow, but the contactor's not pulling in. Remember, I got 3 volts across it. Thermostat's closed. Now I'm going to check across this resistive connection. There, I got 25 volts across the connection. So this is dropping voltage, which is limiting my current, so there's not enough current to pull in this contactor. And this is where resistive connections can be very, very difficult to troubleshoot and isolate. You can usually tell that's what you've got if you pull one of the wires off the coil of the relay or contactor. And if you've got 24 volts between the wire and that with it pulled off, and then when you reattach it, you've got much less voltage. That's telling you somewhere in your 24 volt wiring, you've got a really bad connection. Usually this is going to be where a lot of times thermostat wires get spliced. They may be spliced under the line chase where it comes out to the outdoor unit, where they've just spliced it and just shoved it underneath the line set, line cover. Or they may have it at the bottom of the suction line where they've just spliced it together, taped it up, and it's there near the outdoor unit, and it's just over time just gotten really rusty. Or it could be where the thermostat wiring comes up through a gooseneck on a roof. The wires were spliced there, and so you really are just going to have to trace out and check all your wire connections and make sure that those are good. The other option you can do is if you've got a spare thermostat wire, let's say you've got a brown that you're not using, or you've got a black, you can try switching over to that other wire, but you got to ohm it out first to make sure it's good. Because a lot of times I've seen where, let's say you've got a straight cool condensing unit and you've got 8 conductor. The whoever installed it, when they did a splice, they only spliced the 2 wires that are being used, a yellow and a blue. All the other wires, they're not even spliced. So you may have to go to those connections anyways and check those connections. So that's basically when we're talking about tracing out a circuit, when you're doing a tracing out voltage drop and resistive connection. So if you have any comments or any questions, just write them down in the comments section, and like and subscribe. Thank you.